All right, example 5b, natural log of 2x plus 3 equals 4. First thing I'm going to mention on this problem, this is a logarithmic equation. And the homework we had yesterday, we did a lot of evaluating logarithms, and we found in the process of doing the homework that what I got highlighted there, in this case the 2x plus 3, if that equaled 0 or was negative, it created an empty set scenario, right? So when you get a logarithmic equation, you're going to go through all the work to get your answer, x equals something. You then have to go back to the original problem, the blue highlight, replace x with that number to make sure that you get a positive number. If you get a negative number, the answer you get must be dismissed and thrown out. All right. In a basic level problem like this, probably not going to happen much, but it's a good habit to start because it will happen as we get more complicated problems. Sometimes the answers we get won't work. We'll get 2 or 3 answers. One of the 2 or 3 answers will work, the other 2 won't, or whatever. So just know that whenever you work a logarithm problem, when it starts off log of something equals something, it's up to you to ensure that the answers you get are legitimate, real answers. So, first off, when I see a log problem like this, log equals a number, the first thing I want to see the base. So what does ln mean? Log base what?
E.
Base E. I'd rather write it like this than ln. They mean the same thing, but again, for the sake of what I want to do with this problem, that's a better way of writing. And again, this problem would be present in my book. This is what would be written on my paper. Very first step, I'd write log base E of 2x plus 3 equals 4. Then we're going to do just like we did yesterday with log problems. We're going to rewrite it as an exponential expression. Specifically, this letter, in this number, in this case E, is going to be raised to the 4th power. And that's going to equal whatever we're taking the log of, like so. Just like we did yesterday. Only difference, yesterday, this number could be then transformed right into some number to a power that matches this. Now we've got an algebraic expression happening here. We're trying to get x equals. E to the 4th power is a numerical value. My calculator knows its value. I can just grab my calculator and type it in. Take e to the 4th power, and that equals 54.598150003. Again, I'm going to go 4 decimal places. I want my answer to 3. I'm going to do my work to 4. So 54.5982. It's 1, 5, I think. Yeah, 1, 5.
So it wouldn't
5 makes it go up to 2, right?
Yeah.
All right. Okay, there's no reason any of you should know what e to the 4th power equals without a calculator. So grab a calculator, punch it in, hit equals, and it'll spit out a number. So that's what e to the 4th power equals. And I want to get x equals, and now it's all numerical, right? Just a regular algebra equation now. So if I want to get x equals, first I move the 3 over to this side, so chop 3, move it over. 51.5982 equals 2x. And then we divide both sides by 2, and x ends up equaling whatever that is. So 51.5982 divided by 2 is 25.7991. All right. We went round to the nearest thousandth, so if I go to the nearest thousandth here, it's going to be 25.799. Okay, now, the last thing I got to do now is I have to verify that that number that we got, if I put in for x, is going to create a positive number. It doesn't matter what positive number it is, it just has to be positive. So here's the quick check. I'm not even going to use a calculator for this. If I multiply 2 times that, I get 50 something, right? If I add 50 something to 3, I get 53, 54 something, right? Is that positive or negative? Positive, right? So again, it doesn't matter what the number, it just has to be positive. Okay, if you're not 100% certain it is, you can, by all means, type in 2 times that plus 3 equals, and it'll spit out some positive number. Again, it could be positive 1, positive 0.09, positive 15 trillion. It doesn't matter what positive number, just as long as it's positive. And just like the other problem, I can verify my answer. If I log 2 times that plus 3, ln 2 times 25.799 plus 3, just like that, hit enter, it should equal 4, or close to it because we rounded, right? 3.999997252, pretty doggone close to 4, right? So again, you can check your answers on these problems. You're solving equations, replace x with your answer, it should result in a true statement, or true-ish because we did round. Okay. If it said, if I did that and it came out to 18.97, I'm probably wrong. All right, so as long as it's rather close to 4, we should be right. If it's way far away from 4, you probably did something wrong.